So the group chess chapter 5, question number 1. Rewrite 125 to the power 2 divided by 3 in radical form. So if you have a radical form, it means that this 3 is a fraction, which means it's a cube root. To write that into a radical symbol, so you write this 3 in the cap and 125, which means this is a cube root of 125. And on the top you have a square, so you write this 2 on the top. Now you're going to simplify. To simplify, you write 125 to the power 1 over 3 to the power 2. Cube root of 123. Cube root of 123 is 5 and to the power 2 is 25. So the answer is 25. For number 2, if you see this is same exponent, you can take them outside. So you got here is 63 over 21 to the power 3 over 2 times 2, which 2 and 2 cancel. And now you're going to reduce the 63 over 25 to the power 3. 63 divided by 21 is 3 to the power 3, which means it's 3 times 3 times 3 and it's 27. Question number 3. Given fx equals square root x, write the rule of gx given the transformation vertically stretched by 2. Reflect over the x-axis down 3 and left 7. And the function for this one is going to be gx. If it is stretched by 2, it means that the 2 should be in front. Reflect over the x-axis. It means the negative 2 in the front. Then it's going to be left 7, x minus 7. And then it's going to be down 3. This means down 3, which is negative 3 outside. Now the reflection was and the vertical stretch was in the front. So it means you first do that. If you have to do this vertical stretch or reflection afterwards, then you multiply with the whole function. But you already did that in the front, so you don't have to multiply inside with this number. Now the time is when we are going to graph it. So to graph the parent function, so first we're going to graph the parent function here. So I'm going to graph the parent function, this one, which is 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 4, 2, 3, 9, 3, and so on. So this is my square root graph. And now I'm going to graph the gx, which is a transformation 7 unit to the right and 3 unit down, and then it is stretched by 2, and also it's a reflection. There's 4 things going on here. So left 7 unit, it means that this is going to be addition sign in between. So just make sure that you correct it. There is a 7 plus inside, and left means you're going to go left 7 unit, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 3 down. So negative 7 comma negative 3 is the point right here where the graph is transformed. Now it's a reflection, so it means that the graph is not going to go this way on the infinity side. Positive infinity side is going to go to the negative infinity side for y. And it is also stretched. Wherever my point was earlier, that was this was 1, 1. Now it's moved to 1, comma 2. So it's going to move 1, comma 2. So the y graph or the y coordinate is moved 2 units down because it's a change in y by the factor of 2. So the first point was 1, 1 is moved to 1, comma 2. And the second point was 4, comma 2, but it's moved to 4, comma 4 because it's moving by 2 factor of 2. So 4, comma 2. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So the next point is this one. And which point was this one? It was 9, comma 3. Then this one is going to become 9, comma 6 because every y coordinate is multiplied by 2. Every y coordinate is multiplied by 2, so that because of the vertical stretch. Now you just combine these points and you're going to graph for the, you're going to get the graph for the gx. What is the domain? Now you see this arrow, you need to figure out where the arrow is going. Arrow is going to positive infinity for x and the negative infinity for y. Domain, which is x values, are going to be the -7 and infinity. Minimum to maximum, you have to write minimum to maximum. And let's do one thing here. Make them in a closed bracket. Minimum to maximum, if you write the domain, you got to write -7, comma infinity. And when you write the range from minimum to maximum, you have to write -infinity, comma -3. Always write from minimum to maximum. For number 4, find the inverse. So the inverse has specific steps. What is the steps here is change the fx as y, first of all. And then the next step is to switch. Switch x and y, and you got here is x equals 1/4, y plus 2. -2 on both sides, you got here is x minus 2 equals 1/4y. Now you're going to solve for y. It means that you're going to remove the 4 from the bottom. To remove the 4 from the bottom, you're going to multiply this 4 on each side. So you got here is 4x minus 8 equals y, and we can call it as gx. We can call it as gx because this is an inverse. This is an inverse of the original function fx. Now they're going to ask us to graph because I can see the graph below here. We are going to graph the original function which is fx, and we are going to graph the inverse functions. When we graph the original function fx, let's see if we graph that in this color, purple. You have the y-intercept as 2, so y-intercept is 2, and you're going to move 1 up over 4. So 1 up over 4, 1, 2, 3, 4. 1 up over 4, 1, 2, 3, 4. Same thing, you can extend the line on the other side. So 1 up, 1, 2, 3, 4. 1, 2, 3, 4. And connect these points, and you're going to get the line graph for the fx function. Next is you're going to graph for the gx, which is the inverse of the original function. You start from -8 on the y line. So it's very small graph here. You can use your own worksheet to graph it as I graph on my 1, 2, 3, 4, 5, 6, 7, 8. I pointed this on 8. So this is my first point on a y line is -8. And then you're going to use the slope. Slope is 4/1. Up 4/1. 1, 2, 3, 4/1. 1, 2, 3, 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And it's a this is the graph of the function, that is the gx graph, and then you can also look at for reflection line that passes through the center of these two lines, and it is a y equals x line always. For question number 5, you're going to solve this equation because it's an equal sign. We're going to solve for x. To solve for x, we need to get rid of the radical symbol here. So this is a radical symbol is already isolated for us. So all we have to do is to just make a do some operations to remove this radical symbol. It looks like this is a square. So to get rid of the square root, we're going to take square on both sides so that the square root get cancelled. You got here is x plus 42 equals x squared. You make them into one equation. So you subtract the 42 and x on both sides. Here the equation we got after subtracting, this is cancelled, this is cancelled. You got the equation on one side. It is this equation, x squared minus x minus 42. It's a quadratic equation. If it's a quadratic equation, you're going to solve it by the cross method, where you need two numbers. When you multiply, you get 42 negative, and when you add them, you got negative. The two numbers that when you multiply, you get negative 42 and add to get negative 1 is negative 7 and 6. So these are the two factors you got here. X minus 7 and x plus 6 equals 0. You put them equal to 0 one by one. And you got here x equals 7 and x equals negative 6. Out of these is only one answer going to be true, which means that we have to check for the solution. So we're going to have to check for the solution. First, we're going to check is 7, if it's 7 is a solution or not. So 7 plus 42 equals 7. So this is going to be 49 equals 7. So 7 equals 7. Square root of 49 is 7. And now we're going to check for the other one, which is x equals negative 6. Negative 6 plus 42 equals x. And that's going to be, so this is going to be 36. This x equals negative 6. So 6 not equal to negative 6 is not taken as your answer. So the only answer you're going to box here is x equals 7. The next question is number 6, where you're going to solve for this expression and simplify it. We're going to either separate them, or we can just do it in the same radical. If we separate them, we should know that the square root of 16 is possible. Square root of 16 is 4. Now, for square root, which means that it is divided by 2. The power is divided by 2. If it is a square root of 4, then 4 divided by 2, it just also looks like this. If you want to rewrite it like that, 4 to the power 1 over 2, because square root is the same thing as dividing the power by 2. You got here is 2. So 4 r to the power 2. This is a big number, which is s to the power 51. I change it as s to the power 50 and s to the power 1. The reason I did it because 50 is divided by 2. 50 can be divisible by 2, whereas 51 cannot be divisible by 2. So that's why I separated the 51 as 50 plus 1. 50 divided by 2, because square root means that you're dividing the power by 2. 50 divided by 2 is 25, so s to the power 25. The other s remain inside because it cannot be divisible by 2. So 4 to the second, s to the 25, and square root s. So this is your answer. For number 7, this is a specific question where you're going to remove the radical from the bottom by taking the conjugate. And if you remember, the conjugate is you change the middle sign, and it becomes conjugate. So 2 minus 6 on the top and on the bottom. When you multiply this, it will help us remove the radical from the bottom. On the top, you get 3 times 2 minus square root 6. On the bottom, you got here is applying the formula. So we're going to apply the formula is a minus b times a plus b, and that gives you a square minus b square. So in this case, you have a as 2, so 2 square minus square root 6 square. So what you got here is 3 times 2 minus square root 6 divided by 4 minus 6. And you got here is 3 times 2 minus square root 6 divided by minus 2. You can take the negative up there, so the first becomes, so if you go here is negative 6 divided by 2 and positive 3 square root of 6. So what happens here is that when you divide this by negative 2, so this becomes 6. 6 divided by negative 2, 6 divided by negative 2 becomes negative 6 over 2, and this negative, when you take with the other one, become positive sign in between. That this is you. For number 8, you're going to subtract these two radicals. In order to subtract two radicals, they have to be exactly the same. Like terms in the front, and the radical should be same. And inside number, the radical, which is radicand, should be same. Here we can see the two things are same at least. We can see that they both are square roots. There is no number in the front, they are same, and inside is also not same. It means we cannot subtract them unless we make them same. So for example, we're going to take this 10 and try to find the square root of 10. We do not have a square root of 10, and we cannot break this down in order to get a simplified square root. We keep the 10 as it is. We break the x to the power 5 as x to the power 4 and x to the power 1. On the other one, we can break the 40 as 4 times 10x. Now, for this part right here, since it is a 4, and you can break this because 4 is divided by 2. The square root means divide the power by 2. So when you divide the power by 2, you got here is 2. Square root of x to the power 4 is x to the power 2 outside. Inside you left with 10x. Here x squared. And square root of 4 is 2, and that comes outside as 2. Now if you notice that these are two same like terms. The terms outside are same or like, The radicand, which is the square root, is their like terms. Inside the radical, 10x is same. Now we can subtract, which means that 1x square minus 2x square would be negative x square square root 10x. So for number 9, you're going to take care of this square root. The opposite of square root, which is this 1 over 2, is taking square on both sides. So you take square on both sides. Square root and square cancel. You got 1 minus x equals 49. And as you can see, this is just a linear term, linear equation you can solve. Negative 1 on both sides. Negative x comes out as 48. And when you divide with negative 1 on both sides, you got x equals negative 48. Negative x is 48 and x should be negative 48. You're going to now check for the solution. We always do. 1 minus 48 because x is negative 48, which gives us 1 plus 48 to the power 1 over 2. And this is 49 to the power 1 over 2. 49 to the power 1 over 2 means square root of 49. And then square root of 49 is 7. So the answer for x is correct. This is your answer. X equals negative 48. Number 11 is set the y as fx. Switch x and y. So it means that x becomes y becomes x. Switch x and y. Solve for y. So it means you have to isolate the y if you can. So x minus 2 equals y minus 1 cube. In order to take the cube, cancel the cube, you need to take a cube root on both sides. So cube root on both sides. You got here is x minus 2 equals y minus 3. Cube root of x minus 2 equals y minus 1. Cube root of x minus 2 equals y minus 1. Plus 1 on both sides. You got cube root of x minus 2 plus 1 equals y. And you can write this as gx. So after you find the gx, which is the cube root of x minus 2 plus 1, is the inverse of the given function, you're going to now plug it x as negative 6 because we got x as negative 6 here. You're going to plug it in here. You got negative 6, negative 2 is negative 8. Cube root of negative 8 is negative 2 plus 1 is negative 1. So g of negative 6 is negative 1 as your answer. For number 12, you're going to first isolate the two radicals. So bring that radical on the other side by adding the radical on each side. So what you got here is 2x plus 2 square root equals square root x plus 4. So you want to solve for x. So you're going to take square on each side. Cancel the square root with the square. You got here is 2x plus 2 equals x plus 4. Subtract x on both sides. You got here is x plus 2 equals 4, which means when you subtract 2, you got x equals 2. So you're going to have x equals 2 as your answer. But before we take the final answer, we're going to have to check. So we're going to plug it into the given equation x as 2 and see if we have the right answer. So you got here is 4 plus 2, and this is going to be 6. you got here is 6 and 6. So 6 minus 6 is 0. So square root of 6 minus 6 is 0 equals 0. So this is our final correct answer. So for number 13, given is the function f(x) equals -3 cube root of x plus 2 minus 1. You can identify following and graph both the given function and its parent function. So first of all, we're going to find out the parent function. So the parent function for this one is a cube root. As we can see, this is a cube root of x. It's going to be an odd function because it's a cube root. Now describe the transformation. Transformation is reflection over x-axis and it is a vertical stretch by 3. It's going to be left 2, and for the -1 outside it's going to be down 1. For the parent function graph, as we can see that this is a cube root, we're going to use this -1 point, 0 0 and 1 comma 1. So it goes both ways in both the directions because it's going -infinity to +infinity. So this other one is reflected over the x-axis is a vertical stretch by 3, left 2 and down 1. So if you want to make the graph of reflected function, you're going to move 2 units to the left and 1 unit down. So this is my point, and it is going to be stretched by 3. So this is going to be moved -1 comma -3, 0 comma 0, because when you multiply 0 with 3 it's just 0, and then this is moved 1 comma 3. So -1 comma 3, which means you're going to go down 3 instead of going down 1. So go 1 over 1 2 3. So this is going to be the point, and go over 1 and up 3. Now this is going to be a reflection, so instead of this direction it's going to go to this direction. Domain for the red function or the given function is going to be -infinity to infinity, and also the range is -infinity to infinity, because the cube root function goes both ends indefinitely. So both of them are going to be -infinity to infinity.